In this video we will look at problems from the review section 1.3 in our textbook, and this will be a shorter video because there were really only two problems that people seem to have trouble with, and those were problems number 5 and 25. So let's take a look at problem 5 here. Use analytical and/or graphical methods to determine the intervals on which the following function has an inverse. Make each interval as large as possible. So we're looking at the function absolute value of 4x minus 3. Let's just do a quick recap of things. A function has an inverse if and only if it satisfies the horizontal line test. So probably what we should do is take a look at the graph of absolute value of 4x minus 3. So let's go to our calculator. So we would like to graph, and I'm in the calculate screen, so let's click the toggle switch and we'll go over to graphing. The absolute value function is just given by ABS. So let's just type that in, absolute value of 4x minus 3, and enter. So you can see the graph there. It definitely fails the horizontal line test, but notice that if you can cut this in half, you can pass the horizontal line test. So the question is, where does it bottom out? Where does this, looks like it hits at the x-axis here. So chances are this bottoms out at 3/4, but let's just double check. So if you remember, we go to the menu. This is all on the handout, you recall. We want to analyze the graph. We want to find out the minimum, so that's option 2. So remember, it asks you for a lower bound, so you just make sure you are to the left. Let's find where the cursor is before we do anything. Oh, there we go. Okay, there we are to the left, and now for an upper bound, just something to the right here. And there it says the minimum is at 0.750. And 0.75 is 3/4, so as we thought. So if we split this graph at x equals 3/4, we will split it into 2 halves of the v, each being 1 to 1. So it passes the horizontal line test and has an inverse. So we can cut this off at x equals 3/4. So that means it has an inverse on 2 separate intervals, negative infinity to 3/4, including 3/4, and 3/4 to infinity. So let's enter those in. Curve parentheses, negative infinity, comma, 3/4. Now we need a square bracket, so we'll separate them by a comma, square bracket, 3/4, and comma, infinity, and close the parentheses. Okay. Now let's go look at problem 25. Which involves logarithms. So they are telling us, let's write this down, they're telling us that log base b of x is 0.38, and that log base b of z is 0.85. And they would like you to find this expression. So log base b of the square root of x over the cube root of z. Now this is a good problem because you can't rely on your calculator because we're not actually calculating anything. We don't know what b is. We don't know what x and z are. So we're going to have to rely on the logarithm rules that I will remind you of. The first logarithm rule we'll need is that the log of any base of a over b is log of the numerator minus the log of the denominator. The other log rule I will need to remind you of is that the logarithm of something to a power is that power times the logarithm. So now using that, we can simplify log base b of the square root of x over the cube root of z. Well, first of all, remember that the square root of x is actually an exponent, x to the 1/2, and so is the cube root, z to the 1/3. Now we can use the division rule, log base b of x to the 1/2 minus log base b of z to the 1/3. And now we'll use the exponent rule to write this as 1/2 log base b of x minus 1/3 log base b of z. And since log base b of x was 0.38 and log base b of z was 0.85, a little arithmetic will get us the answer here. So that's something you can just type into your calculator and you get negative 0.09333 and so on. And since they only ask for 4 decimal places, we'll be able to type that in. So let's check our answer. Negative 0.0933. And there we have it. So those are the two in section 1.3 that people seem to have trouble with.